Small models are amazing. They're fast, they're cheap, they run pretty much anywhere. And they get a lot of jobs done pretty well. And the tech world is definitely becoming a lot more diverse when it comes to large language models. There will always be a place for those enormous models, for those GPT-4s and Llama 4 or 5Bs. But right now, the second half of 2024, large language model-based applications become more and more mainstream. They actually become part of our daily lives. And with that, they start facing the challenges of scalability, of price, of speed, and just simply to deal with all the different things that people want from them. And while the super large language models start plateauing slowly but surely, like that, the small large language models are closing the gap really, really quick. Like they become better really fast. At this point, you've got 7 billion parameter models, which are really, really tiny, that can do the job that used to be, you needed GPT 3.5 for that just a year ago. Because they are so small, it actually is feasible to train them on your own data and make them really good at the job that you need them for. So all of that taking together just makes the market for small large language models, the demand for small large language models, grow super, super fast. And that's where Instructlab comes in. Instructlab is an open source project that helps you manage the data that you need for training and create synthetic new data, which is super powerful, and then use that data to train a small model. So let's check it out really quick. There's this project and it's got its main repo, which is the main Instructlab repo. It's pretty popular by now, 600 stars. A lot of people working on it, 124 contributors, mainly from IBM and Red Hat. You can see that there is a pretty extensive README there, and that pretty much explains everything you need to do. And it's important to know that this does not just come out of the blue, but it's actually the manifestation of a research paper, which is called Large Scale Alignment for Chatbots, and somehow they came up with the acronym LAB for that. I don't know. As everyone knows who's working with large language model, it's really simple to just throw together a lot of chains and make large language models do cool stuff, but make it in a way that is reproducibly producing good results is really challenging, and you really need a scientific method for that. That's what Instructlab is. It is based in hard science and it's engineered to be efficient and easy to use. So now let me explain to you what Instructlab does in my own words. I want to break it down to three main concepts. Number one is a way to handle your personal, your company-wide training data in a very opinionated way that makes it easy to keep track of it. The common way it's done right now is you just take a bunch of knowledge that you, take from your company wiki or just some online sources, and you dump them in a bunch of TXT or Markdown files and throw it on a big pile. That works pretty well as long as you who did this is still in the project and kind of still remembers what happened. But as soon as your project grows, as people come in and out, this concept just simply collapses and you just end up with a huge pile of more or less useless data. To do that differently, Instructlab proposes what they call a taxonomy approach, and they break every piece of training information up into 3 categories: knowledge, foundational skills, and compositional skills. I don't want to go into a lot of detail what the differences are. They're explained in great detail here in the paper or in the other repos. But the idea is that every piece of information finds its place in this taxonomy, and somebody else can find it again and check if this knowledge has already been added. And it also gives you some really nice ways to, it's out of the box, it's got a Git-like approach to dealing with data. And actually, the way that it makes it easier for teams to work together on collecting data is probably been an afterthought for the authors of this paper. That's something that comes to my mind because I work with large customers all day, and that's the pain that everyone is fighting with. But the original reason why it's done like that is because it's super powerful when you want to go to the second and third step of the system that I'm explaining to you, and that is to create synthetic data and to use that synthetic data for training, because then you can do different things for different categories. You can deal with knowledge differently than with foundational skills, and differently than with compositional skills. And that turns out to be kind of the secret sauce here. So this picture is nice, but it's kind of abstract. There's a really nice example that I will actually do a demo here at the end of this video, and we'll be using that very example here. And that's a bit more tangible. This is a example for a Q&A YAML, and most of the things you represent in Instructlab are in this Q&A format. Like you always get a question and an answer. And this Q&A snippet lives in this folder hierarchy. So at the end of the day, taxonomy is a really fancy term for a folder structure. And in this case, the folder structure is knowledge, textbooks, culture, movies, awards, Oscars, and this is our Q&A YAML here. Additionally, in the case of knowledge, you always have a repo here that gives the context. And if we check this out, this is a very large markdown file. I think it's just simply taken from Wikipedia. And this will be used in the generation of synthetic data together with the Q&A parts to create a pretty large amount of synthetic Q&A pairs. But I'm getting ahead of myself here because now I'm already talking about the second pillar of those 3 pillars. And that is the synthetic data generation. The main idea is you take a corpus of knowledge, in that case, this markdown file that we've just seen, and then you manually create a set of so-called seed examples or seed Q&A pairs, just some questions and answers about this corpus of text that kind of represent that kind of knowledge that you want to get out of it. And then Instructlab uses this text and those questions together with a really large model, preferably what they're called a teacher model, to create a large number of synthetic question and answer pairs. And this is a really powerful trick. I mean, running Llama 405B is super expensive. Like, it's a gigantic model and it costs a lot to run. But that way, you only have to run it once for like an hour or 2 and create the synthetic data that you want that would otherwise take weeks or months to create manually, and use that to train your small model. Like, it's actually pretty genius. We will see what that means in practice in a few minutes when I show you the demo. And the third pillar is what the authors of the paper call multi-phase training. And it's a pretty clever training approach that's mainly supposed to be very efficient and particularly be efficient against catastrophic forgetting. Like this phenomenon when you learn something new and you forget something old for it. I've been told that's not actually a thing in humans, but it really is a thing in large language models. I'm not going to go into detail here, but the key idea is that you leverage this taxonomy approach and you first train the knowledge and then train the skills, plus a lot of fine details to it. But that is the secret trick that is actually not secret because here in the paper, but that is a lot more efficient than just throwing the whole pile onto QLoRa, which actually under the hood, this is QLoRa, and hope for the best. Like, this actually works really well. So let's jump to the demo. At this point, you pretty much need an Apple with an M1, M2 or M3 chip, or a Linux system, preferably with a more or less powerful GPU. I have a Windows system with a crappy GPU. What I ended up doing is just simply rent a VM and use that as a demo environment. You can very well do that on Google Colab. I just really like Lambda Cloud, not affiliated with them in any way, but it's just a really good service for a really reasonable price. And at this point, I think I have a A6000, which costs me like 80 cents an hour. I have a repo here where I have a very simple notebook. And there we go. So first things first, let's do some installs. This is specifically 0.17. Obviously, when you watch this video in the future, try to use the newest version available. And for some reason, I had to reinstall Llama CPP to a specific version. Otherwise, I couldn't get the GPU to work. This is not exactly supported, but well, it works for me. The last command here in the list is ilab sysinfo. That gives us a summary of the configuration. And if we look here, it says GPU offload true. So we have full GPU support, which is pretty relevant since we are running a pretty substantial A6000 GPU. Next, we configure the models that we want to use. And I highly recommend going with a beefy model. The defaults suggest that you use Granite or Merlinite, I don't know exactly, as a teacher model. But I don't think that's a very reasonable choice. I mean, you want to use a preschooler as a teacher to teach another preschooler? I don't know. It definitely works a lot better when you use a college graduate model. So a big one, a Mixtral 8x7b as a teacher. So I would highly recommend that. Here we do some configuration of the Instructlab CLI. Nothing too exciting. You can go into detail if you want, but this works for now. And here we are actually downloading the models. This ilab model download, kind of the default, this downloads Mulit 7b. That is a version of the Mixtral 7b that has already been trained using the Instructlab method. So this is already an improved version of Mixtral 7b. And this will be the model that we will be further training with our specific knowledge. And here we download Mixtral 8x7b. We download that using Hugging Face repository. We can actually use the Instructlab CLI for that, which is kind of convenient, but it's a pretty substantial 20 gigabytes. So this will take a moment. So much for the generic setup. Now let's get specific. We add our own data now. What we've chosen, I've chosen, simply because there's a really good example about that in the Instructlab taxonomy repo, are the 2024 Oscars. They are obviously way beyond the knowledge horizon of pretty much any model, just because they're pretty new, March 10th, like just a few months old. They're definitely not within the knowledge corpus that the model was trained on. So if we check the raw model, which we will do in a moment, it performs miserably on those questions. As I've mentioned before, the way we present data to Instructlab is highly opinionated. You don't just dump information in there, but you have to explicitly provide seed examples, which are always Q&A pairs. For example, when did the 2024 Oscars happen? The answer, the 2024 Oscars were held on March 10th, 2024. But those questions, in that example, there are 12 of them, but the real knowledge is hidden down here. I've shown you this before, and it is simply the Wikipedia article about the 2024 Oscars. And this will be the base, the context that will be handed to our teacher model together with some of those example questions. Our teacher model will come up with a lot additional Q&A pairs to cover this whole topic. And those Q&A pairs will be the main thing that will be used to actually train the model later. I just created 2 terminal windows and started a model server in one terminal and a chat window in the other. It's all described here. And this is using the very raw, naked Merlinite model that does not know anything about the 2024 Oscars at this point. So let's just try and see what output we get. It's going to be horrible, I promise. When did the 2024 Oscars happen? Okay, it took place on February 24th. Yeah, that's just hallucination, like unusable, unfortunately. Actually, worse than unusable. What film had the most Oscar nominations in 2024? Let's try that one. Also going to be horrible. 2024 Oscars are yet to take place. Well, that's actually kind of true from the perspective of that model. I would actually count that as a semi-win. What film won the Oscars for Best Picture in 2024? Best Picture has not been announced yet. Well, again, that's actually pretty true from the perspective of the model. So you get the point. It's not able to answer those questions. But we are going to change that. And let's run this cell. Oh, and there it goes, generating synthetic data. 500 iterations. We do have a bit of a version issue here, but it works fine. So here is our first example. Who presented the awards for Best Visual Effects and Best Film Editing at the 2024 Oscars? Arnold Schwarzenegger presented the awards. Blah, blah, blah. And there we go, a lot of warnings. And here's the next one. And the next one. And that way we're going to generate 500 Q&A pairs. It's going to take a while. The reason why that is because there's actually some pretty sophisticated prompting happening behind the scenes here. You can dive deeper when you look into the paper, but it's actually generating suggestions, then evaluating those suggestions, then creating answers, evaluating those answers, the factfulness of those answers. There are quite a lot of steps happening before this Q&A pair pops out. It's just not trivial to create high quality synthetic data. And well, Instructlab does that for us. So this has been running for like an hour. Those are some of the examples that came out of it. We've already seen a few of them. One thing I want to point out, that one's actually incorrect. Generating synthetic data is not a hands-off process. It's a human in the loop process. You have to check those synthetic data points. It's not guaranteed that they will be correct. Most of them are, but some of them are not. And it's important that you catch them. But for us, that's good enough. So we're gonna run the training. Oh, this might take some time. One thing I want to point out here, number epochs, the default is 1. And iterations, the default is 100. In my experience, those defaults are way too low. Those numbers worked for this example for me pretty well. So this is gonna go on for quite some time here. Even though the training part actually is surprisingly fast, it's probably gonna take like, I don't know, 20 minutes or something. After about 30 minutes, we are done with our training. But at the end, it saved our trained model here, and now we can evaluate it. We've got our server here again, and here we run our chat window. I limit it to 100 tokens because the model for some reason developed the habit of just keep on talking. It's kind of weird, but if you limit it to 100 tokens, it's really good. So let's try a few things. Who hosted? No one. The most awards. What's at the 2024 Oscars? Film Oppenheimer. 5 awards. Well, that sounds pretty good. Who hosted the 2024 Oscars? Let's see. Hosted by Jimmy Kimmel. Oh, yeah, there we go. It's kind of developed the habit of citing sources. I don't know exactly where that comes from. It's probably due to the way that the synthetic data is presented to the model. So there's a lot of ways to improve this. Let's ask one more question. When were the 2024 Oscars held? March 10th, 2024, Dolby Theatre in Los Angeles. That sounds pretty good. Again, just trying to quote some sources, which is kind of nice, but might want to add a stop sequence here. So yeah, we just successfully taught our model about the 2024 Oscars. I think it actually was not all too hard. That was a fun toy problem. Well, it worked, but in reality, you would not solve a problem like that with fine-tuning. Getting factual knowledge into a large language model based system, you use RAG, retrieval augmented generation, for that. It's easier and you can easily change the information that the system is retrieving. Where this fine-tuning approach really shines is solving the long tail of problems that you have with large language model applications. If you have an agentic workflow and there are things that workflow gets stuck at and you know the problems, you can generate data to solve that exact problem and create a model that is really good at solving your workflow. Or for example, if you've got German language, like I'm German, large language models always suck at German. It's always the same. Other languages are even worse, but it's just way harder to get a large language model to do anything in German. And for example, if you want the model to quote properly, I mean, we've seen that model do quotations, even though we didn't want it to. But that's, for example, something you could teach a model with a skill, a compositional skill, and make it capable of doing this task really well. And this might be crucial for your application. I hope you learned something. And as always, if any of this was interesting, reach out to me. LinkedIn, Twitter, YouTube, wherever you want to reach me. I'm always happy to chat. Thanks. Bye.